Today is November 30th, 2024. It is exactly 2 years ago on this day that OpenAI released ChatGPT, and we know rest is history. How that has changed everything that we do is now driven by IT. The latest buzzword that has entered our space is AI agents. But are AI agents such a groundbreaking concept? Or are they destined to be forgotten in our chase for the next shiny object in generative AI? That is the topic for today's It Depends podcast. I am so glad you joined us today as we are going to take a deep dive into the topic of AI agents. For those of you who know me, my name is Sanjeev Mohan. I run my own analyst advisory firm called Sanchmo. Prior to that, I was at Gartner. I am also an author of a book called Data Products for Dummies. As you can tell, I host my It Depends podcast. A lot of content that you will see today comes from my latest blog on my site, which is sanchmo.medium.com. So I hope you get a chance to read the content of my document because there's some really critical questions that we're going to cover today. So let's go through our agenda. We have a lot of material to cover, but we're going to start with some very basics, such as what exactly is an AI agent and how does it even work? Once we talk about what an AI agent is, then we need to create a baseline. So we're going to look at many different examples of different types of AI agents, followed by a discussion on what is the journey of generative AI since the 2 years it's been since ChatGPT came out. So we talk about copilots, assistants, chatbots, and so on. These three questions really help us set the baseline of what an AI agent means. After that, we change tracks and we go very deep into the technology aspects, starting with what is the life cycle of an AI development process, followed by what is the architecture, what are the components that go inside an AI agent. We will then follow up with a brief discussion about AI agent framework, and we will end up with a final question, which is what lessons have we learned and what pitfalls should we avoid? Now, that is the scope of today's talk, but that is not the entire gamut of questions I get. There are plenty more questions I get, such as, is this the right time to invest in agentic AI? And if so, how much of my existing investment, including skills, can be leveraged? Who has successfully implemented AI agents? What happens in 2025 when the reasoning capabilities of large language models start increasing more than where we are this year? And finally, how do we get started? Now, these are the questions for which we will have to wait for the next episode of our podcast and the next blog. We have plenty of material to cover for today's session. So let's get started with our first question. What is an AI agent? A very basic answer is it's a program or a system designed to automate tasks and operations for humans and organizations. At this point, you may be asking, is that it? That's all it does? Automation? Well, what's such a big deal about it? Well, I'm glad you asked. Because you may be thinking that, organizations have already had things like robotic process automation, RPA, for a long time. So what makes an agent so different from RPA? The first point I want to mention is that it leverages the power of foundation models to make these automations contextually very rich and autonomous. What do we mean by that? Is that large language models have this ability to understand the instructions that we give in a natural language create these similarities and semantics, and then they are able to predict what is the next best action. That is because they've been trained on the world's data, large amounts of data, and so they're very good neural networks that can do all kinds of pattern recognition and predict the next token. But that's not all. If that was it, that would be very limited in its use. The thing that makes it different is that it's expanding this automation by including cognitive tasks. These cognitive tasks require some thinking, reasoning, problem solving, and then they take actions. So let's stop here because is this all theory? What do we mean by cognitive tasks? So let's start looking at some examples to drive home the point. Let's say I have an agent, it's a scheduling agent. The job of that agent is to read my emails and then understand the content of that email and then take some action. For example, I may have received an email from somebody who's requesting a meeting. So maybe what it does is it reads the email and it says, okay, I'm going to schedule a meeting on your calendar. Maybe it detects that email is a spam and it deletes it. Maybe it detects that email is from my boss or from my angry customer and it needs to be escalated. So it's going through this reasoning process, coming up with some list of tasks to do, and then it's taking the right action. A lot of this reasoning is actually what is based on how humans interact. In a very famous book by Daniel Kahneman a few years ago called Thinking Fast, Thinking Slow, he introduced this concept of system one thinking and system two thinking. System one thinking is how we react. Instantly, somebody asks a question and we have an answer ready. System two thinking is where we're doing a lot of retrospection, we are thinking, we are reflecting, and we're coming up with a more thoughtful answer. System two type of thinking is what some of these new reasoning models are doing, and this is what's making an agent so much more productive. For example, OpenAI came out with their reasoning model called O1 Preview only recently. There are a couple of more reasoning models that have come out of China. One is called DeepSeek R1, and other one is from Alibaba called Qwen 2.5. So these new models are helping these agents become far more intelligent, and of course, they're autonomous. But just like in any probabilistic case, there could be hallucinations, there could be accuracy problems. So let's not forget that these agents work and interact very closely with our traditional software engineering approaches to improve reliability and accuracy. So now that sort of explains what is an agent. But let's look far more deeper into an agent to really drive home the point of how does an agent really perform its job. There are four stages that an agent goes through. The first one is called sense. In sense, it perceives and interprets the environment, which then it sends to the reasoning stage that breaks the desired outcome into granular tasks, creates a plan of action using the most optimized way of executing, and then acts upon these subtasks. So let's take an example. What do we really mean by sensing, perceiving the environment? Let's say there is an agent for sales development representative in an organization or an SDR. Why did I pick SDR as an example? Is because we recently had a conference from Salesforce called Dreamforce 2024, in which they actually launched an autonomous agent called the SDR agent. Microsoft also had its conference earlier this month called Ignite 2024, where they launched 10 autonomous agents, SDR being one of them. So the SDR now has an agent. It is a digital worker or a digital twin of what an SDR does. This agent is perceiving the emails that are being received by the SDR while the SDR is out busy selling to another prospect or having a beer with a customer or maybe even watching Netflix. Who knows? So the SDR's agent receives the email. In this case, the environment is Microsoft Outlook. It perceives that the SDR had requested a demo to a prospect. The prospect has replied and said, I'm sorry, I'm not able to meet at this day. Can we meet at a different day and time? So the agent will now schedule, it'll create a list of tasks. One of the tasks may be to schedule reschedule the meeting. Another task would be to send an email back to the prospect confirming the new meeting. Let's take another example. Let's say it is a call center agent. The call center's agent is to perceive that a new call recording came from a customer. Now, this customer call recording is then sent to a model that does speech to text conversion. That text is then parsed by the large language model to understand its contents, what is the desired outcome, so that it can then create a plan of action to act upon. That set of that perception of what the email or the in this case the call recording contains will tell the LLM or the agent how to act. For example, the customer may be calling to thank the organization for excellent service, a great product, and everything works out of the box. Well, if that's the case, then the LLM detects its positive sentiment. It says the next best action is to send a thank you email back to this customer, and the job is done. Well, most likely the customer called because their part does not work, it's faulty, and the customer is angry. In this case, the agent will determine that it needs to schedule a replacement part. It needs to print a return mailing label. It needs to reach out to the warehouse or the inventory management system and schedule a replacement to be emailed to this certain customer and know what the address is, for which it may have to dip into its memory and find out what is the address of this customer. So you can see that that the range of tasks that an agent can do can be quite complex, simple to complex. It could be as simple as scheduling a meeting to as complicated as orchestrating a whole supply chain process. So as a result, there are many different types of agents. So let's take a look at the next question. What are the different types of agents? In this case, what I've done is I have divided the space by using a 2 by 2 quadrant into 4 different areas. At the bottom are these task oriented. So when we say task oriented, these are generally single task based agents. On the top are more agents that are more built for executing the work performed by a different role. Now, you'll see on the left-hand side, it says narrow scope. These are also known as narrow agents. And then we've got broad agents. So this is also the scope of what the agent can do. Let's take an example by starting at a personal agent. In this case, I have taken the example of a shopping assistant. A shopping assistant is built to help a individual research, find out what are the different products, and then decide what gifts do I want to buy for the upcoming Christmas season, let's say. In fact, let's take an example of Perplexity. Perplexity First went after Google by creating an AI-powered search engine. Now they're going after Amazon by creating an AI-powered shopping experience. It allows me to research different products in different categories. And if I have the pro version of Perplexity, the paid version, then I can even do one click, place an order, and it will do all the calculation of all the taxes and fees that are applicable to my region. So as you can see, in this case, a shopping assistant may have gone from just recommending and researching to placing an order. So we can jump over this way to a broader scope. But let's look at more narrow agents. Here is a task-based agent. It has one and only one job, which is you are responsible for making travel booking. Now let's move to the right-hand side where we still have a task agent, but now the scope is much broader. It's fraud detection in this example. In case of fraud detection, I'm not only detecting an anomaly, but I may also be doing some root cause analysis. I may be executing some remediation. I also have to send emails, notification, alerts to the right people in the hierarchy. So you can see that the scope is now becoming wider, and there are series and series of tasks. You chain these tasks together and you get a process agent. Now, when we move up to a role agent, in case of a role agent, we may not be just chaining the tasks that fall under processes, but chaining a number of processes to something that's performed by a role, like we talked about SDR. But it could be even more than that. It could be a data analyst. A data analyst or a business analyst comes to work every day, looks up some dashboards, runs some SQL queries, checks the output of some queries. Some of those tasks can be combined. A DevOps engineer could have an agent. So there could be a number of these agents that perform all the functions of a particular role. I mentioned that earlier this month was Microsoft Ignite 2024. At the beginning of the CEO's keynote, he talked about 4 different types of agents: personal, organizational, cross-organizational, and business function. So that is the example that Microsoft gave, which can be fitted into this. But my point here is that there are many, many different classifications of agents. So this is not the only one. This is what I chose based on scope and function. But we have agents that are delineated by the type of architecture. Is it neural network based or is it rule based? We have types of agents that are based on how they learn through reflection or through some utility or goals. And so there's also agents that are human based, or they're based on or semi-autonomous or fully autonomous. So this is not the only classification, but there will be many, many different types of agents. I want to give an example of OpenAI. OpenAI has defined their 5 levels of agents, level 1 through level 5. Level 1, very simple, straightforward. Workflow could be like task-based personal agents, all the way up to level 5. As you go up these levels, you start seeing these agents could go from $20 a month to $20,000 a year, or something quite a lot. The value or the cost of an agent will be directly proportional to what complex problems is it solving and what value does it bring to the business. Now, let's take one final look at some conceptual topics before we change tracks and start going deeper into technology. Here, what I wanted to do was I wanted to lay out a number of overlapping terms that we've been using, and they cause some sort of confusion. So I wanted to clarify, what do these terms mean? Let's talk about the famous RAG. Everyone's talking about RAG these days, retrieval augmented generation. The purpose of RAG is to take the power of generating text in an LLM or any foundation model, but then enhance it with knowledge that only exists in an external source. For example, it could be in my corporate database, an operation database, or an analytical system. It could be in all the PDF documents that exist in my organization. So by combining these two things, I can then create outcomes that are far more relevant and also far more accurate. In fact, there are many variations of RAG. There is graph RAG. There's something that Microsoft just came out called lazy graph RAG. So there are so many different options of doing RAG itself. But my focus is mainly on the next ones: chatbots, copilots, assistants, and agents. So what is the difference between these? Chatbots are what came out first. A chatbot is simply a wrapper that is calling an LLM's completion API. What does it do? It is doing what an LLM does the best. It predicts the next word. To be technically accurate, it predicts the next token. So I can now use chatbot. I can say, here is my document, summarize it. Or I want you to write me a piece of code to create a website, and here is my prompt. I'm giving you what I would like to see. And it says, okay, thank you for your prompt. Based on all my worldly knowledge, here is the code. And you're done. So that's a chatbot. And it's still AI powered. It's not the same chatbot that used to exist many years ago, which were very rule based on some decision tree. You go to a website, the chatbot will show up. These are far more intelligent chatbots. What happens when you go to copilots and assistants? This is when we add the power, or we add the action piece to it. So it is no longer just predicting the next word, it is doing something about it. For example, a very common assistant or a copilot is to help me with coding. Now, what it does is, not only can I ask it to write me a piece of code, but I can also say, thank you, now that you've written this code, I actually want to run it faster. So I don't want it in Python, I want it in C++. Translate this into C++. Or take my old legacy Java code or COBOL code and move it to Java. I can also tell this copilot, which is embedded inside my IDE, or I'm using something far more sophisticated like Cursor or Replit, where I can also tell it, hey, I want you to document this new code that you've written. And while you're at it, translate it into French, because a lot of my colleagues are in France. I want them to be able to read what this code does. Also, maybe I want you to create me some very interesting graphics and embed them into this IDE. So go call Flux Stable Diffusion Model and also create me a PowerPoint deck while you're at it. One thing that I dread doing is writing test cases. So I'm going to ask my copilot to write me unit test cases and then go run some experimentation and test it out. So this is what we are doing with copilots and assistants. But notice one thing. I've been giving these instructions. There's a human in the loop that is asking it to do something. As we get into agents, we become more autonomous. The role of humans starts to get lesser and lesser. We still have semi-autonomous agents where human is in the loop. But then we go to fully autonomous where there is no human. It is perceiving my environment. It's interacting with my environment. It's creating my desired outcomes into subtasks and it is acting upon them. So with that, let's take a look at our first question on technology. I have a number of slides on this. I have a 5-item process flow here, which or the life cycle, which I've called Agent Development Lifecycle, ADLC. I on purpose chose ADLC as a term because I wanted to draw some parallels with what we have come to know very well as SDLC or software development lifecycle, because there's a lot of similarity between how you develop an agent and how you develop software. But there are also some very major differences because when you develop a software application, you develop it once, you test it, you make sure all problems are taken care of, and then you then deploy it into production. Once it's deployed into production, it's very deterministic. It's going to work exactly how you coded it, and you can now move on to the next version of the applications, and you can start adding new features into the next release. But not in the case of agents. Agents have a much tight, closed loop because you have to constantly monitor it. Agents are based on randomness. So that means that they may actually give you a different answer. And hence, we have to very carefully monitor how exactly are the outcomes being delivered, and then take action on it. So human in the loop is still a very common thing, even for these autonomous agents. Let's look at each one of them one by one. Use case development or use case planning is very similar to how we do it, but the scope here becomes very critical. When we go to the last question of today's session, we will talk about lessons learned. In that, the first the first issue I hear from organizations that have put agents into production talks about how they have struggled with coming up with the right scope. Is it developer productivity? Is it customer success? Is it an agent to help me do research? So sometimes I've heard organizations take or they determine the scope based on non-mission critical projects. For example, I could have a research agent. This research agent's job is every day go out into the internet, find out what new publications have come out for my industry. Maybe it is drug development, and I'm in pharma, and then summarize those findings and present it to me. So this way, I look intelligent. I don't have the time of the day to be looking for these publications. Another scope could be in marketing. My job is to do competitive intelligence. However, in my space, there are new companies that are always coming up that I may not even know are competition. So I have an agent. This agent's job is to go crawl the internet, find out who's doing work that is very similar to mine, then call an external function that goes, and we will talk about function call in the very next slide. Go uh, call the browser and then scrape the website, bring the information back in JSON format, and then start doing similarity search and telling me how this competition is similar or different in their pricing, their go-to-market, and so on. So you see, I'm defining my scope and I'm defining the granular task very carefully before I embark on my agent development journey. I also have to worry about scalability, performance, reliability, all the things that I worry about. But now I also have to worry about the ethical and bias considerations. So this is one more place where agents are going to differ. I do want to mention that recently there was a survey done by LangChain, called State of AI Agents 2024. They had 1,300 respondents. They found 50% of organizations already have agents in production. Another 80% are experimenting with them. So the next step is, how do we design our agent? Once again, we are going to rely on classical software engineering and classical machine learning. In software engineering, we've done a very good job of designing how REST APIs can connect to a database, extract information. How do we do error handling, error recovery? All those best practices are leveraged in our LLM system design. Also, on the machine learning side, we've become very good at optimization techniques like hyperparameter tuning, feature engineering, looking for model drift, and things like that. So we are also going to borrow those concepts. LLMs are actually very interesting because large language models have actually sort of converged two things: language and intelligence, because it is also a decisioning engine now. But not all decisions can be made by LLMs. So that's why we have this ability to do function calls. A function call could be an API. It could be saying that the LLM I'm using is breaking all records on a benchmark called math that tests for its capabilities of executing math formulas. But for my use case, I want you to do a function call to a Python function because I have my own math module, and I want you to call that into your execution. So this is how we design agent. If there's one heartbeat of this entire agentic architecture life cycle, that is evaluation. Evaluation is very tricky. So let's take some examples of what do we mean. So the first step, by the way, is to do a test case development. A test case development could be, I have a data analyst agent. This data analyst connects to a series of databases and then run some SQL queries. So I want to have the ability to run the same SQL against the same database. Now, how do I evaluate whether this agent is performing poorly or correctly? For that, what I do is I take the output of my SQL query, I compare it with what I would have gotten out of a non-agentic, and I compare. Now, this is, if it matches, it is a quantitative yes, and the test can pass. But what if it's a research agent that I mentioned, where it's bringing back some hardcore research, but summarized into key talking points? How do I know that information is accurate? How do I know it's complete? How do I know it's of the right length? So this is a very tricky thing because there are no benchmarks for this. This is where the agent has to become really good at qualitative testing. In fact, this is where we may not even be able to use a human to test and tell us whether this outcome was correct or not. So we have to use yet another LLM to be the judge. So LLM as a judge is now another area which is coming out. And I just found out that there's a leaderboard called Judge Arena that is listing out some LLMs that are good as judges. But it is a much bigger problem. The problem here is that when we get into the agentic space, we are building very custom, purpose-built agents which could have very complex workflow. I cannot rely on an external benchmark. I have to create my own. So I have to create a series of what questions do I ask, what answers do I get, and that becomes the baseline for me to evaluate my agent. And the agent could be calling multiple LLMs too. So it becomes complicated. So once I evaluate, I then test my agent. I report on my findings. Once again, you can see that I have this box here called human eval, because humans are still very critical in evaluating whether this agent is ready to be put into production. After this agent is put into production, you see an arrow coming up here that says continuous improvement with inputs from deployment and monitoring. So this is where we are continuously testing whether this agent is behaving properly or not. So with that, let's go to the two last steps, agent deployment. Nothing different to report here. These agents are, hopefully we can deploy them through something that we will look at towards the end called agent framework with one-click deployment, deploy them wherever we want, public, private cloud. And typically these could be an endpoint, could be a Kubernetes managed container. Monitoring and observability becomes the crux of making sure we are successful with a properly scoped agent. So we may be looking for not just the output, but common consumption metrics. As you know, that these LLMs cost comes from tokens. The cost for input tokens and output tokens. So in case of having an agentic lifecycle, we need to monitor what is the consumption of our agents through prompt and completion tokens. What is the trend of this consumption over time, over different subject areas, completion status, and has this ability to drill down and see the details. This reminds me of in data management, we have this whole concept of lineage where we can go from very high level conceptual, we can keep drilling down till we see the exact SQL statements that were executed. So we have the same thing instead of a DAG doing lineage, we are now doing observability on the agentic workflow and seeing what conversations took place and what subtasks were executed. With that, we go to this one diagram that is a little bit hard to read. My apologies. It's much better in the blog and has some more details. But this is a architecture. This is the brains of how an agent works. So we start on the left-hand side. We have a box called user interface. This user interface is most likely a conversational user interface. So think of Databricks launched something called AI BI. It's a very interesting name. AI BI. What do you mean by that? Well, they're taking the power of BI because BI reports, dashboards are so well established, but they're putting a conversational interface, a user interface in front. The job is so I can talk to my BI instead of going to a form and saying, please run this report, I can now talk to it. But a user interface is not necessarily just a conversational. An agent could be talking to another agent, so it could be taking directions from another agent. A user interface could also be visual. Maybe the agent is embedded in cameras in Disney World for crowd control, for safety purpose. So it is reading, it is taking the video as an input and then understanding what's going on in that video and sending. So that's an environment, it's perceiving, it's sensing what's going on, and then it is sending that information to a task planner. This task planner's job is to break this task into many, many subtasks, which then the plan executor will execute. It will come out with the answer, but this answer needs to be verified. If the answer fails verification test, it goes back into the loop. If it passes, then it goes to the user interface. Now, what is most important, so all of these things are super important. In fact, let me just also mention, how is this task planner working? How does it even know what tasks to generate? Here in the small print, there are many, many techniques that are used. Chain of thought reasoning, few short examples. There's something called GOT here, which is instead of chain of thought, it's graph of thought. So this is a growing field where the reasoning techniques are being developed to help in determining the right level of subtasks. On the top is a shared resource layer. This has many critical components. The first one is an LLM provider. An LLM provider's job is to provide the right LLM. For example, if it's an agent for coding, maybe I want to use the newest Claude, Anthropic's Claude Sonnet model. If it is for maybe translation, I may call Google's Gemini model. If it is for some text generation, I may call OpenAI's GPT-4. So that's the job of an LLM provider. Sometimes I may have to go outside the boundaries by doing a function call. So a lot of toolkit has all of these connectors and integrations into helping the agent perform its duties. Memory is an extremely important piece because we've got multiple agents have got multiple tasks. So we need a common shared resource library where memory can be shared. We also have this concept of short-term memory, which could be only for the task or for a session, or episodic memory, which could last a number of tasks that are being executed. There could also be long-term memory of I'm trying to understand what is my customer's address so I can send the returned product. I also would like to see what are the preferences, what is the buying history of my customer. In that case, I have long-term memory, which could be my relational database, my document database, my vector databases, where I have all of customers' information kept. In fact, I was reading a few days ago Mustafa Suleiman, who was with Inflection AI, DeepMinds before that, and now is with Microsoft, has this concept called infinite memory, where these agents will remember things for life. In the shared layer, we have common things like event logs and tracing, session management, task management, security and governance, because we are not going to just launch these agents without proper rollback access control and things like that. So that is agentic system architecture. How do you build it? So as you can see, there are so many different components and pieces that go into building an agent. Am I expected as a developer, to know all of these pieces? No, my job is to help deliver the business outcome. So an agent framework is what comes into place where it abstracts a lot of the nitty-gritty details that you saw in the previous slide by helping me focus through maybe a low-code development tool where if I want to execute RAG, I can say, here is my external source of PDF documents or my database, and here are my instructions, my prompt. I want you to take this prompt and run a RAG pipeline on it. In fact, I've even seen some of these new frameworks even have a button that says improve my prompt. It can even help you write, so you can just put whatever prompt you want and it'll write you a very specific prompt to get the best use of your LLM. It may even have a pro code SDK where you can write your program. But the idea is that inside this framework, I can do experimentation, I can do my testing, I can use different models before I put anything into production, do some verifications, and then I can put it into productions. To make things easy for me, I may have a set of templates. Maybe those templates are for my particular domain. I have ability to customize things, call external functions, like some of the things that we've talked about, like an image model, because it has connectors, it has integrations. In fact, at Ignite 2024, Microsoft talked about its framework, which we will see on the next slide, where it talked about 1,400 integrations and access to 1,800 plus large language models. It also talked about 10,000 users currently using its framework. also has enterprise features like governance, security, observability. So, what are some examples? When I did my research, I found there are over 50 examples. Some are open source, some are not, and I could not add all of them. So I only took a few. I listed them in alphabetical order because there is not one that I'm calling out. Some of these are getting a lot of traction, and some are still pretty new. You can see here, I'm tempted to go through some of these, but the there's so much detail, and this is such a moving item, fast moving space that the whole AI agent framework deserves a whole blog and a podcast by itself. And so we will leave this topic for now and we will move to the last question, and which is lessons learned. But I just wanted to mention I did put something to demonstrate how big this stack is. You can see here, by the way, I found this graphic accidentally while crawling through LinkedIn to give proper attribution. This belongs to a company. They're right here in Agent Framework called Letter. So letter.com has a blog on their website where they classified the stack with vertical agents, agent hosting, observability, framework, of course, and a bunch of different categories. You can also see that some companies have products that are across this gamut. For example, we've already talked about LangGraph in the previous slide. Actually, we didn't call out any other products, but LangChain has something called LangGraph, but you can see they also have LangSmith for observability, LangMem here for memory. So there, there is an ever-growing uh, ecosystem. This sort of will become, Matt Turk has his mad landscape. I think in a few years, this will become a whole mad landscape of itself just for AI space. Which takes us to the last topic, which is lessons learned. Here, what I did was I listed two things on the top: planning and scoping as two biggest challenges. A lot of people think agents are not ready for prime time because of all the hallucinations and complexity, but the biggest problems are not in technology. Yes, technology has problems. It is in unrealistic expectations, incorrect scoping and planning of these agents. So start small, make sure the agent can be autonomous, make sure it has well-defined series of subtasks as we've discussed already in this talk, and then scope it correctly before you start developing. When you start developing, then technology is immature. Agent frameworks are only now coming into existence, and there are many of them, but it's just a matter of time. In fact, I would say it's a matter of 12 months before we start seeing that these agent frameworks have become very sophisticated. They are already improving literally on week by week basis on how this technology is getting better. There's also improvements happening in the reasoning capabilities of large language models that we are starting to see at a very rapid space. Skills is the next big problem. This is very interesting because we are so used to thinking in very deterministic manner, and now we have to start thinking and make peace with some hallucination, because that is how this new world of Gen AI is going to be. Finally, inability to demonstrate value is something I hear a lot. One problem is because we are seeing that it's taking a lot more time to build these agents. We expect to have fast iteration because that's how software development is through agile, but we are not there yet. The good news is that the cost of tokens has come down 100x. So the technology cost is going down, but but there's skills, there's all this tooling that is taking a lot of time in delivering value. With that, we come to the very last slide. Let's talk about some summary. Let's talk about what's going to happen to agents in the next coming few years. I want to mention some very interesting statistics here. When cloud first came out, SaaS products came into existence. The joke used to be that a SaaS product is nothing but a wrapper over MySQL with some user experience and a workflow. So guess what happened with the AI LLM landscape is exactly the same thing happened. We started seeing a profusion of these companies that were nothing but wrappers over LLMs. But then over the next 2 decades of cloud, 17,000 SaaS companies came into existence. 337 of them have unicorn status. We are going to see the same thing happen. However, the pace or the rate of acceleration is so much higher that it won't be 2 decades, it'll be much sooner before we start seeing a spate of AI companies. Some of the things like different modules in ERP, accounts receivable, accounts payable, fixed assets, journal entry, some of those monolithic pieces of code in my thinking could also turn into agents. But then we're going to move from deterministic to stochastic cognitive applications. So this whole mind shift needs to happen. We've talked about frameworks lacking functionality, but they're improving rapidly. Planning and scoping is really important. How important it is to evaluate your AI agent before you put it into production is a determinant of whether it's going to be a success or a failure. And then keep an eye out that in 2025, as reasoning capabilities improve, we are going to start seeing a massive improvement in these agentics. And with that, we come to an end of our session. You've been an amazing audience. Thank you for staying all the way till the very end. And until next time, we will end our session today. Thank you. Bye bye.